Welcome again to another lesson of circle geometry with me, of course, Mr. M. Today we'll be tackling the circle, the converse theorem. Wow. Last time we tackled the first theorem, and we say that we are having a converse of it. Then what exactly is the converse? Well, we will see. So now we are tackling converse theorem 1. As said, we are saying it states that a line drawn from the center to the midpoint of the chord is perpendicular to the chord. So basically, we are saying that that line that is drawn, this line, when it gets to the midpoint of the chord, it should form an angle of 90 degrees. Interesting. So basically, this is asking us to prove the first theorem. Right. This is asking us to prove the first theorem. And the first theorem was actually asking us to prove the converse theorem. Can you see it? So I need you to understand that. So now the keywords are the midpoint. The midpoint is a point in line halfway through. That is the point, or where the 2 points meet. That is a point where the 2 lines meet. So it is a point of division where this line was actually divided, or what? In our word, bisected. Perfect. So now we're saying perpendicular. Perpendicular, we have learned that it is something that is a line that will form an angle of 90 degrees with the horizontal. Right, it forms an angle of 90 degrees with what? With the horizontal. Perfect. So now we are moving on to the terminology again. The terminology that is used here also, it is still a chord. Remember, a chord, it is the line drawn from the circumference of the circle, passing anyway to the circumference of the circle, except what? Except the center. Perfect. Except the center. So now we are going to check how our diagram is. We can see that this is a line that is drawn from the center of the circle, and then this is our chord, and this is our bisected chord actually, or we have found the midpoint of it here. So because we have found the midpoint of it, what are we required to prove? We are required to prove that this part here, it actually forms an angle of 90 degrees. Even this part here, it also forms an angle of 90 degrees. Right, that is what we are required to prove. So firstly, we are going to do what? Label our diagram A, C, and B. Perfect. After labeling our diagram, we need to learn how to do what? Right. Right. After labeling our diagram, we can see, okay, now what is our required to prove? Right. Our required to prove is what? Is that the O angle CA, right? O angle CA is equal to O angle CB, right? And they are both equal to what? To 90 degrees, Right. That is what we are actually required to prove. So this O angle CA basically means that we are looking at a C that is subtended, or enclosed by OA. We will learn that a lot when we speak about subtending angles. I'll try to simplify it for you. And then we are also saying that this is the C that is subtended. We can see when we stand at a C there, and then when we stand at a C there, we can see when we stand at a C there. But yeah, doesn't matter. So now we are saying when we stand at the C there, we can see that actually this angle it is enclosed by what? By this part, which is OB, hence subtended. So now this is our required to prove. And our second step, remember, after writing our required to prove, we need to do what? To construct. And when we're constructing, we need to let them know what exactly are we constructing. So we are going to say we are constructing a radii OA and what? And OB. Always on theorem 1 and the converse of it. So you're going to do what? To construct the radii OA and OB. So we're going to do exactly that to say that constructing radii or radii OA and what? And OB. Perfect. So now we're constructing the radii OA and OB. So what else are we supposed to do? So now we are going to do our formal proof. With our formal proof now, remember, always give what is already given. So we go back to our diagram, we can see that, okay, we have given that AC, it is actually equal to BC. Ladies and gentlemen, this lines actually tells you that this is equal to that. Okay? It does not tell you that this is parallel to that. It tells you that AC it is equal to what? To BC. So basically that is what is given. So you're going to write AC is equal to BC. And what is the reason? It is given. We were given that AC it is actually equal to what? To BC. So now we're going back again. We come to what is already there. OA it is equal to OB. We can see that because we have constructed the radii and I have said the radii of the same circle, they are always equal in length. So now because we know the radii are equal in length, we're going to come here and write the radii that we have constructed is radii OA. It is equal to radii OB. And then what is the reason here? The reason is that they are the radii. And lastly, what you can give is the common. So you can see that OC will actually appear on both triangles. If I try to take out these triangles, I'll have triangle OCA and triangle OCB. So now we can see this OC is actually the same as OC. So I can't say I have an X and you also have an X. So these X's are the same because they have the same name and they have the same structure and they are portrayed the same. Unless I have the X1 and then you have the X2. That's when we no longer have the same thing. Are we okay? Thank you. So now we're coming back to say we are having the OC equal to OC because it is common. Sorry about that. Well, we are saying we're having OC is equal to OC, which is common. Right. So they are common because it appears on both triangles. Now, ladies and gentlemen, we have proven three types. And remember what I said? You need to give us three reasons why. Reasons why that is true. So now you have given three reasons why. So now you have to now get into it in triangle what? In triangle OAC. Actually, my writing it's getting bad. Let me erase. Perfect. You're actually going to say fish in triangle OAC and triangle OBC. Right, and triangle OBC. So you're going to do what? In it, you are going to say that the triangle OAC it is congruent to triangle OBC. You are going to state the reasons why. The reason is because you have proven with a side, and a side. So basically it's S. So that is your reason. So now therefore, that's when you conclude, therefore, the RTP, it was what? It was O angle C B equal to O angle C. It was O angle CA. It is equal to O angle CB. So therefore, it is equal to 90 degrees because of what? Of congruency. You will say because OAC, it is congruent to triangle OBC and side. And that's it, ladies and gentlemen. Hope you enjoyed this lesson and you get to understand there are many ways to kill a cat. Others do it differently, but trust you me, this is how I know how to do it best. And it will give you all full marks. Remember, you are having 5 marks for this question. So here you already have 3, you already have 4, and then the last one will be from your constructed diagram. Now, ladies and gentlemen, next on the next lesson, we will now move on to the second theorem, which states that the angle at center is double the angle at the circumference only if they are subtended by the same chord or arc. Ladies and gentlemen, please take that into consideration and we'll see you on the next lesson. And please subscribe for more lesson videos. Thank you and bye.